So what I'm going to do today is I'm going to walk you guys through a typical professional level maintenance step by step. We're going to go over readings, what they mean, and how to look for these little problems that run in the background that are not detectable even when your system is cooling the house down. First thing I do when I walk in through the door is I'm going to check the air filters. And the reason why you're checking the air filters first is because with a dirty filter or no filter at all, if you don't check that first and you go through the system and take all your readings, when you go back and put a new filter in, it's going to change all your readings because that filter is affecting airflow. That airflow can affect a lot of different readings like pressure readings, temperature readings, electrical readings, and so forth. So you always want to start with a clean filter before you do anything else. Once I confirm I have a clean filter in the system, the first thing I'm going to do is I'm going to go and start on the indoor unit. And the reason why I prefer starting on the indoor unit is because when I'm out by the condenser and I'm washing the coil down, a lot of times you end up with a muddy area, and I don't really want to track that stuff into the customer's house. So I prefer starting indoors first and then finishing up outside. So one of the first things I do when I get up to the air handler is I shut the power off and I look for a way to access that evaporator coil. Now this is an often neglected part of maintenance. A little insider secret: maintenance is often an entry-level position in this trade. You have a lot of young guys who don't know a lot about HVAC performing these jobs. A lot of times they're just riding with a guy for a couple of weeks and then boom, they're out on their own and they're not really doing a thorough job. So whenever I'm doing it, I always check that evaporator coil because even if there was a maintenance performed a year prior, there's no guarantee it was cleaned. Now when you're checking a coil, you want to make sure you're checking the right side of the coil. There is a clean side and a dirty side. So the dirty side is often on the return side. It's usually the opposite of where the blower is located. So a lot of times getting access to this coil can be a little bit of a pain. Sometimes it requires taking the return duct off the back of the unit. Sometimes you might see a unit that's panned off with just flex on it, which I don't recommend ever doing, but if I do find it like that, I will just take the flex off. I'll be able to access the coil right there. Sometimes you get lucky, you have a 4-inch pleated filter connected right to the coil there, and you can just take the door off and the filter out, access it that way. Sometimes you can just take the door off the coil itself, but either way, you want to make sure you're on the dirty side of the coil and you want to inspect it and clean it. Now when it comes to cleaning a coil, I prefer using a no rinse coil cleaner, and keep in mind, just because it says no rinse doesn't mean it doesn't need to be cleaned off. The idea behind a no rinse cleaner is that once you turn the system back on again, all the condensate that's generated on the evaporator coil will rinse it off on its own. But if you're doing a maintenance early in the season, you know the system's not going to run for a few days or maybe a couple of weeks, you do want to rinse that stuff off. Usually I'll just use a spray bottle of water. Sometimes I'll even use Simple Green, but you don't want to leave it on there. You do want to take it off. So generally what I'll do is I'll spray that stuff on. I'll take a brush. I'll brush the coils down. You want to make sure you don't bend those fins in the coil because that will start restricting airflow. So be very careful not to do that. Another thing you want to keep in mind is when you clean this coil off, that dirt, if there's a lot of dirt in there, you don't want to leave it in there and sitting in that pan. You want to clean that pan out because that dirt can potentially plug up the drain line. So make sure you get all that out. Now I usually carry an empty 1-gallon container for maintenance purposes. I will fill it up with water and then I will dump the whole thing out into the drain pan. And I will just do this to flush the drain pan out, any extra dirt that's still in there. Once that's done, I will go ahead and I will close everything back up. Whatever I needed to open to get to the evap coil, I'll reclose it and then I'll start inspecting the drain line. Now when you're looking at the drain line, a lot of times you might see there is no T in there to access it to clean out the P trap. Sometimes they don't have unions put in there. I will put in there what's necessary for me to do another future maintenance there to easily access and clean out that drain line. So if I need to, I will cut it. I will put a union in. But whatever you do, you want to go ahead and clean out that P trap. You want to make sure you clean it out really well. A lot of times I will dump a bunch of Simple Green in there or some other kind of cleaner and just clean that out. Once that's done, I will go ahead and I will blow it through with a little air gun, or if you can access the other end of it outside, I will take a shop vac and suck it out. At that point, I like to fill the P-trap up with a little bit of Simple Green, and I'll just leave it there. Now, once I have the coil side of the system all closed up, the drain lines all cleaned out, what I'm going to do now is I'm going to pull the door off the blower side of the air handler, and the first thing I'm going to do is I'm going to inspect the squirrel cage on the blower motor itself. Take my hand, I'm just going to spin it, see how freely it spins, and I'm going to inspect to see how much dirt is on the blades of the blower wheel itself. You'd be surprised how just a little bit of dirt building up on those blades actually restricts airflow. When you think about it, if each one of those blades has 2 or 3 millimeters of dirt on it, the amount of spacing between one blade and the other starts to shrink. And when that spacing shrinks, you're now moving less air, and it can be a lot of air that's being restricted on a really dirty squirrel cage like that. And as I said earlier, airflow can lead to pressure changes, electrical changes, and all kinds of other changes. So if you do find a very dirty blower motor, don't just dust it off. The reason why you don't want to do that is because a lot of that dirt will end up sitting in the bottom of the casing, and once the blower turns on, it's just going to be blowing through the ductwork, or in some cases might even go straight to the coil if you have like a furnace with an evaporator sitting on top of it. So if you do find a very dirty blower motor wheel, you usually do have to pull it out. Maybe sometimes if it's just a little bit, you can get a shop vac in there and just kind of suck some of it off. But generally, pulling a blower motor is not part of an annual maintenance. That's a whole job by itself. It can take some time to pull that thing out. So that is in addition to a maintenance. It's not part of it. So if you do find that, it's time to talk to the customer. Now, next thing I do is if it has a capacitor on it, I'm going to test the capacitor. Now, the first thing you want to do is you want to disconnect the wires from it, and you want to take a screwdriver, and you want to run the screwdriver and touch both of those tabs together. And what this does is it discharges the capacitor. These capacitors, they can hold a charge to them, and if your fingers end up being across both of those things, you're getting a nasty shock. Now, there are capacitors out there that self-discharge. You don't really have to do that anymore, but I'll be honest with you, I don't know how to tell the difference just by looking at them. And even if I could read the label or something, a lot of times these labels are covered, you can't see them. So I just discharge it with a screwdriver just to be safe every single time. Now, when you're testing a capacitor, there's a reading on the side of it that tells you how many microfarads you should be reading on that capacitor. There will also be a second number with a plus minus next to it, and that is a percentage your actual reading should be from that reading on the label. So the way you take a microfarad reading on a capacitor is you want to take your multimeter, you want to go ahead and you want to put it on MFD. You can see right there, that is your microfarads. You want to go ahead and you want to put it on there, and you take both of your probes, you put it on each of the spade terminals on your capacitor, and you wait for your reading. Now, once you have your reading, what you want to do is take the microfarad reading on the capacitor itself, multiply that times whatever the plus minus is, so say it's 5%. You take that 15, multiply it by 0.05, and that number you get is the amount of room you have plus or minus from 15 that you should be reading on your meter. So for example, 5% of 15 is 0.75. So your microfarad reading in that case should be somewhere between 14.25 and 15.75. A lot of times a capacitor will still go even if it's close to that 5%. A lot of times I'll let it go a little closer to 10 before I actually recommend the customer replace it, but that's how you test the capacitor. So once I'm done testing the capacitor, I'm going to go ahead, put it back in, put the wires back on it, and what we're going to do now is test for amperage on the blower motor. Now, there are different types of blower motors, but generally what we're looking for is for our blower to be running at full capacity, and in most cases you're going to look for a black wire that goes from the control board to the blower motor. That black wire is the tap for the highest speed on the motor. Now, sometimes you might find something a little different, so what I suggest doing is taking your multimeter, put it into the ohm setting, which is usually that little horseshoe there, and you go ahead and you clamp on the black wire. And what I'll do is, instead of running down to the thermostat to turn the system on, I'll just take alligator clips and I'll run a jumper between R and Y. If you have a two-stage, you want to go between R and Y2. And then once you have your alligator clips set up, you have your meter on ohms clipped onto that black wire, you want to go ahead and turn on the switch to the unit and go ahead and let the blower run. Now if you find you're not reading any amperage on that wire, you might have to try a couple of different wires. Sometimes with these blower motors, there's different wires for different speeds, and the customer, you know, they complain that the system's too loud and they want the blower at a lower speed, so a technician prior came along and maybe changed it from black to blue, for example. So just keep looking for that wire where you're actually reading amperage off of it. But just make sure the system's running at full capacity. Now what I like to do is I like to get a true reading. When you have that blower door off, you're not really getting that. And obviously it's a little hard to read your meter with the door on there, because very rarely can you get the meter with the door on and actually read it. So what I'll do is I'll hit that max setting once the system's up and running and I actually have a reading on my meter, and then I'll put the door on and I'll hold it on there for a few seconds or so, take it back off, I'll look at my max reading, and that will tell me what my amperage draw is on that blower motor with the door on it. And then I just take that number, and there is a data information plate somewhere on that air handler that will tell you what the full load amperage is on that motor. And so what you're looking for is a reading somewhere close to that. Now if you do find you have a reading much higher than what's on that data label, then that could be an indicator that maybe the blower's starting to go bad, maybe the bearings are starting to go bad, something along those lines. Now once I'm done taking the amperage reading on the blower, since the system is running, I'm going to take this opportunity to test any float switches that are up there. So if you have an inline float switch in the PVC, what I'll do is I'll take that cap off, I'll flip it upside down, and that will replicate a high water situation. Now depending on how these float switches are wired in, a couple of things can happen. Some guys wire these things in to break the red wire, in which case the whole system should shut down. That being said, there is often a time delay on the blower, so even though the system is shut down, the outdoor unit is shut down, the blower motor will continue to run for 60 seconds, 90 seconds, sometimes 2 minutes, sometimes it feels like forever, but it will eventually shut off. You want to sit there, be patient, make sure it shuts off. Now in some cases the guys will break the Y signal to shut the unit down. What that does is it just shuts off the outdoor unit. The blower motor will continue running indefinitely. So you want to make sure, if you don't know which one's which yet, I mean if you're still not comfortable with that kind of wiring, you just want to make sure that the condenser unit outside is not running. A lot of times if you're close enough, even though you might be up in an attic, you can hear it turn on and off. Sometimes what I'll do is actually put my hand on the copper line, on the bare copper, to see if I can feel refrigerant flowing through in there. Sometimes if you just can't tell, you just got to go outside and take a look. But either way, you want to check your float switches, you want to make sure they work. And this is really important to do, because a lot of times if you miss something when you're cleaning the unit and the drain line does end up getting plugged, you want to make sure that float switch is there to work for you, because it's not just saving the customer's ceiling or floors, it's also saving you. So always check that. One other thing I'm going to do is I'm going to check the drain pan itself. I want to make sure there's no debris in there. If there is, I want to clean it out, because the reason why is once that pan ever fills up with water, all that debris is going to start floating towards the drain line and it will plug it up. Once that's done, I'll clean everything up. I'll put the door back on the unit. Make sure you take your jumpers off. There have been a couple occasions where I've forgotten to do that, and I'm down the road on my way to the next call. Dispatch calls, customer says their unit's not shutting off. Sure enough, I forgot my jumpers between R and Y. Now once I'm done with all that, the system's all put back together and cleaned up, I'll clean up the outside of the unit, get all the dust off of it and everything, and then I'll take a quick look over the duct system itself. Now a lot of times I will find ductwork where the insulation is starting to fall off, and wherever you have bare metal in a very hot attic with a duct system that's very cold, you're going to get condensation, and that can create water damage that you want to avoid. So I always take a quick look over, look for little things like that. If I find anything, I'll tape it up, I'll seal it up. You also want to check dampers. Sometimes a customer is complaining one room's a little warmer than the other. You want to go through, make sure all the dampers are open. If I do happen to find any dampers that are closed or partially closed, I will check with the customer before opening them back up. Maybe he was up there climbing around doing it himself. but you do want to check things like that. Now, before I finish up and leave the attic, what I want to do is take a temperature differential reading across the evaporator coil. So I have UEI probes that I use for this. I put one in the return side, I put one on the supply trunk, and you want to try to stay close to the unit as possible on both sides, and you want to actually read what your temperature difference is between these 2 points. Now, you don't have to use probes, you can use any kind of thermometer, whatever you've got that reads temperature would work just fine. But basically what you're looking for is a ballpark between 18 and 22 degrees. That is kind of where normal lies. If you see something outside of that range, it could tip you off there's something going on with your system. Now, considering that you've already checked the filter, already cleaned the coil, it might not be an airflow issue. So that if I find an abnormal reading at that point, after I've already done my maintenance in the attic on the unit, I will know that I need to start looking for something on the outdoor unit when I go out there and start there. So once I'm completely done with the air handler, I will head outside to the condensing unit, but on the way out, I'll stop at the thermostat and I will put the thermostat into cooling mode. And there's two things I'm doing here. First, I'm testing the thermostat. I'm making sure the whole system comes on. And the other thing I'm doing is I'm kind of setting myself up for later, because when I'm all done outside with the condensing unit, instead of coming in with muddy boots to turn on the thermostat and run the system, all I need to do is turn the power on outside and the system will start off running and I can do whatever I need to do out there. Now, once the system kicks on, what I want to do is I want to go straight out to the condensing unit and I want to pull the disconnect out. I don't stop at the truck, I don't set up, I want to go straight there and shut that outdoor unit off so that I'm not actually cooling the house down yet. Now, keep in mind, when you're pulling a disconnect, whatever hand you're not using, you don't want to be touching the condensing unit. You want to be touching anything else. You want to make sure you're clear when you pull it, because if there's ever a problem with the grounding on that disconnect, you never know. I mean, I've walked up to some pretty shady disconnects. If you are touching anything and there's not a proper ground in that disconnect, you will get electrocuted. There has been code updated within maybe the last few years where a disconnect now has to have 3 feet of clearance in front of it exactly for this purpose. There's been too many guys that have been found slouched over a condensing unit because of issues like that, because the disconnect was hard to get to. So always make sure you do that very safely. What you want to do then is you want to take that handle and flip it upside down, put it back in the off position, and close that disconnect up so that's protected from water, because we're going to start washing the condensing unit and you obviously don't want water splashing into that disconnect box. Then at this point, what I'm going to do is I'm going to go ahead and I'm going to open up the top of the unit and take the fan motor off so that I can access the inside of the unit. Now, some units are made that this is very easy. It's just 4, 5, 16 screws, zip, 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 comes right off. Other units, kind of a real pain in the ass. You got to take out like 15 screws, but either way, you really want to clean these coils from the inside out, because as debris starts to build up on the outside of a unit, if you're trying to wash it from the outside in, all you're doing is pushing that debris in between the fins on the coil and you're just clogging it up even more. So with most of the dirty material on the outside, the dirty side, when you push water through there from the outside, from the inside out, you're washing it all away from the coil instead of into it. So that's why we do that. You also want to clean the debris out of the bottom of the unit, because a lot of times that debris will start building up and it'll start clogging up the drain holes that are in the bottom of there. And eventually, after a while, if you don't take care of that, you're going to have a lot of standing water in there. It could start creating rust issues and all that kind of stuff. So you want to clean that out, make sure it drains properly for rain and things of that nature. Now, a lot of manufacturers these days, they don't really recommend using a chemical cleaner on the outdoor unit. A lot of times I just use Simple Green. It's good enough. The only time I actually will use a coil cleaner is if it's really dirty. I mean, there's a lot of dirt on there that's obviously been neglected for years and years and years. Then I'll use a cleaner, but otherwise a little Simple Green and just a little bit of water pressure will do. Now, when you're cleaning the coil off, I'll spray both sides of it. I'll spray the inside, I'll spray the outside. And when you start rinsing the unit from the inside, you want to work your way from the top down. Now, you can do this with a zigzag back and forth like this, rinsing all the dirt downwards, or you can go in rows from top to bottom, top to bottom, either way. I kind of like going back and forth, but you want to flush it out nice and good. You want to make sure none of that material on the outside is getting stuck in between the cages, in between the coil and the cage itself. If you can remove the cages, that's even better, but you really want to make sure that coil is clean. You want to rinse from top down. You also want to be sure you're not using too much water pressure. I mean, you don't want to use a pressure washer or anything, because if you have too much water pressure, or if you hit the fins at the wrong angle, like say here's your fins and you're hitting water pressure from this angle, you can end up bending those fins over. Now, funny thing, the first time I ever did this, I was like a teenager. I was rinsing a coil off and I was using really high pressure water, and everywhere the water went, the coil got really shiny, like super shiny. I'm like, wow, I got this thing really clean. I was flattening the fins out, and that's why it looked so shiny, because I was seeing the sides of the fins flattened out, and that obviously restricts airflow. So you don't want to use super high pressure water. You just want a nice strong stream, and you want to hit it head on. Once I have the coil clean, I'll take the opportunity with the fan motor up to actually clean off the blades. A lot of time you'll have slime build up on there. It doesn't look good. I like to clean that off, make it look nice and pretty. And then once I'm done, I'll go ahead and I'll close the top back up, put the sides back on if I take those off, and I'll button the whole thing up again. And then at that point, I will take the access panel off, and I'll start looking at the electrical inside. Now, a lot of times you're going to find spider webs, you'll find mice nests in there. There's all kinds of garbage that you find in there. That little hole that the low voltage comes through for the contactor, there's a lot of critters that climb up through that hole, even mice. I never thought they could fit through there, but they can. A lot of times what I'll do is I'll take one of those hard plastic Romex connectors and I'll just shove it up in there to seal it up really well. We'll go ahead and clean that electrical compartment out. I usually use a little brush I keep in my bag. Afterwards, I'll blow it through. And then once that's cleaned off, what we're going to do is we're going to test the dual capacitor. Now, just like the other capacitor we talked about earlier, take a screwdriver, you want to touch all the terminals together to discharge it, and then you want to remove the wires from the terminals. Now, if you don't know wiring very well, I strongly suggest you take a picture before removing the wires so you know where they go back. Now, what we're going to do is a microfarad test once again. The only difference with a dual capacitor is that there's two tests you have to perform. So on this side of the capacitor, you'll see two numbers. It'll be 50/5, and then you'll have your plus minus 5%. So, or sometimes it's 7%. It depends what the label reads. So that first number, the higher number, that is the microfarad reading for your compressor. And you will take that reading with your probes between common and HERM on the dual capacitor. The second number is the microfarad reading for your condenser fan motor, and that reading will be taken between common and fan on a dual capacitor. Now, sometimes you can't read the COM, HERM, and fan lettering on the top of the dual capacitor because it's kind of worn out or rusty. One way to tell the difference is the common terminal is almost always going to have the most number of spades on it. So that'll have 4 spades coming off of it where you can connect wires to. The fan terminal is going to have the least. Usually it only has 1, sometimes maybe 2. The HERM or the compressor terminal will be the one in between. So 4 common, 1 or 2 fan, the one in between is your compressor. So if you get confused, that's how you tell. Once that checks out, what we're going to do is now we're going to check for amperage readings on our compressor and our condenser fan motor. Now, what I like to do first is take the locked rotor amp reading. Now, if you look at the data plate it's usually on the panel that you take off, you'll see a rating LRA. And then you'll see a number there. What that number is the maximum number of amps that the compressor will draw from a standstill position. So that's the number you're kind of looking for when the compressor first starts up and draws the most energy. In order to take this test, you want to take your multimeter, you want to put it into the amps position. Then what you want to do is you want to clamp on to the common wire coming back from the compressor, which goes right to the top of the contactor. Now, a lot of times this will usually be a black wire, but you can check the wiring diagram that's on the panel cover, trace the common back from the compressor, and it'll tell you what color the wire is. When you have your meter ready to go, you want to hit max because you want to get your max reading, and then once you have that set up, you want to very safely go ahead, put your disconnect back in, and allow the unit to start up. And you want to get your max reading and compare it to that LRA rating on the data plate. Now, if you're reading in that ballpark, you have a good compressor, it's nothing to worry about. If your reading starts to exceed that number, the more it exceeds, the more laborious your compressor is trying, to have a hard time starting up. Now, sometimes when the numbers start to a little bit exceed that, it could be fixed with like a hard start kit or something along those lines, but usually that's a temporary fix. But this is a sign that the compressor is kind of like on its way out. Now, once I have my numbers and I check that out, I'll leave the system running and I will take my multimeter, I'll leave it right where it is, and I will take it out of that max hold position. The amperage reading that you would be reading at that point is your run load amp reading on the data plate. This reading is usually going to be a lot lower than that max. If you do find that the reading is getting close to that maximum, there's a few things you have to take into consideration. You might have problems with restrictions in the refrigerant line. Maybe it's overcharged, something along those lines. So you really have to start investigating elsewhere to find out what the issue may be. So next we're going to check the amperage draw off of the condenser fan motor, and it's going to be done on the common, which is going to be a wire running from the condenser fan motor right to the top of the contactor, sort of like the compressor did. That is also on the data plate as well. If we look back at our schematic, that will usually tell you what color that wire is. You go ahead and just clamp it on that wire and take your reading. Once again, we just want to make sure we're not exceeding these ratings on the data plate. Once that's done, I will just go ahead, take a quick look over connections. Once again, I'll check pinch points and all that. And then once I feel good about that, I'll go ahead and close the unit back up again. And what I'll do now is I'll take a quick temperature reading between the ambient air coming into the side of the condensing unit and the hot air coming out of the top of the unit. And a lot of times you'll read somewhere between 10 and 15 degree difference there. I'll look for little things like if the condensing unit's not pitched properly or not balanced, I might try to level it out. Now, there are a lot of guys out there that at this point, if everything else is reading properly, if their delta T's upstairs are looking good, if the delta T on the condensing unit itself is looking fine, everything else seems to check out at that point, there really isn't much of a reason to hook up your gauges and check pressures. I mean, the odds are really, really, really good that the pressures are right where they need to be in order for all those other temperatures to be where they need to be. But if you do have to hook up and check your pressures and your subcooling, basically what you're looking for is a subcooling or a superheat reading that's usually indicated on the data plate information on the unit itself. So a lot of times you will see subcooling 9 degrees or 10 degrees or whatever it may be. So a subcooling reading, this is when you have a TXV on the indoor unit. What you want to do is you want to put your temperature probe on the smaller liquid line and compare it to the pressure you're reading on the high side gauges. And the temperature at the gauge and the temperature on the actual copper line itself should be a 10 degree difference or whatever that subcooling rating is on that data plate. That's what you're looking for. If it's a lot higher or a lot lower than that, then you either need to add or remove refrigerant. And of course, if you do need to add refrigerant, that can be an indicator there could be a leak in the system somewhere. At that point, when I'm all done, I will go ahead, fill out the paperwork, and then I will go to the front door, tell the customer I'm all done. I have the paperwork right there, just sign, and I can tell them you can go ahead and put your thermostat wherever you like to set it, and I don't have to go back into the house. So I'm all done and off to the next one. So I hope that helped you guys out. Let me know if it did. Thanks for watching.